Hello YouTube, this is Ringo from 7 Education, and today we are back for more video. We are going to go over a section B, a long question of the paper 1, the May 15 paper 1 TZ1, and this question is going to be on vectors. So let's take a look at the screen. So a line L passes through the point A and B. Show that AB equals that. Alright, so first thing first, what you guys will need to be able to remember or recall is that there are two types of vectors. One is called the positional vector, and the other one is called the directional vectors. So the positional vector tells you where it is, directional vector tells you which way it goes. So I always tell my students, whenever you see these questions, positional vectors are always based on something. It's always based on origin. So, when given this, you can directly draw a triangle like this. You have A meaning it's actually OA, which is minus 2, 4, 3. B, which is OB, which is minus 1, 3, 1. And now we're asked to find AB. So simply just write this for me first. OA plus OB, oops, not OA plus OB, because they're not in the same direction. It's actually OA plus AB equals OB. That was simple. So AB is simply OB minus OA. Whereas OB, we know is minus 1, 3, 1, minus OA, which is minus 2, 4, 3. So to get this, minus 1, minus 2, we get 1, minus this, we get minus 1, and that we get minus 2. Voila! This is how we calculate the answer for AB. Alright, moving on. We're asked to find the magnitude of AB. So magnitude of AB is very simple. So we recall that we have this as AB. What we're going to do is we're going to go for 1 square plus minus 1 square plus minus 2 square, and we take the square root, and that is how we find the magnitude, or what we call the distance between A and B, which is simply root 6. Okay, so let's keep going. Find a vector equation for L. So any vector equation usually requires you to write something such as this, where A is your positional vector and B is your directional vector. So in this case, R will simply be equal to minus 2, 3, was it minus 2, 3, 4? Yes, well, 2, 4, 3. Minus 2, 4, 3, plus our directional vectors of AB, which is 1, minus 1, minus 2. It is as simple as this. And can you use the other one? Can you actually use minus 1, 3, 1? Of course you can. It doesn't matter. The mark scheme will accept both. Alright, so moving to the next part. The following diagram shows a line of L and the origin O. The point C lies on L. Point C has a positional vector of 0, y minus 1. Show that y equals 2. Alright, remember this? Remember what we had earlier on? We had the vector equation of this. Do you guys remember? Was it 1 minus 1 minus 2? 1 minus 1 minus 2. So, because we know that it's a straight line, the point should be passing through it. So we're going to sub this into our R. So what we're going to get is this. We're going to get 0, y minus 1 equals minus 2, 4, 3 plus t 1 minus 1 minus 2. So what we're going to get is 0 equals minus 2 plus t, y equals 4 minus t, and minus 1 equals 3 minus 2t. So we have three equations. Focus on this one first. So if I rearrange this, what I'm going to get is t equals 2. And if t equals 2, y equals 4 minus 2, therefore y equals 2. That is how you solve it. Okay, quite easy. So the next part you learn is that you're going to multiply two vectors together. Alright, so how do we multiply that? Well, let's write it. The OC is 0, 2, minus, was it 0, 2, minus 1? 0, 2, minus 1, yes. Times AB, which is 1, minus 1, minus 2. So what we're going to do is going to go for 0 times 1 plus 2 times minus 1 plus minus 1 times minus 2. So we get 0 plus, actually minus 2 plus 2, which is equal to 0. And that is the answer. Hence, find the size of the angle between OC and L. If it multiplies together equals 0, we know that simply by recalling the rule, it forms a 90-degree angle, or you can write this as our beautiful pi over 2. Works well. For the last part, hence or otherwise, find the area of the triangle OAB. Ooh, this one is a bit nasty, I think. Because we're looking at OAB, we're looking at the triangle. I can't draw a straight line. So let's try that again. Trying to find that. But we know that this is a right angle. Okay, so if that is that, we are going to need to go for the big triangle minusing the small triangle. But before we can do that, we need to find magnitude. We learned that OC was 1, 2, minus 1. 0, 2, minus 1, my bad. 0, 2, 2, minus 1. Alright, so the magnitude of this is going to be 0 squared plus 2 squared plus minus 1 squared, which is, you take the square root, which is root 5. So we know that this is root 5. Okay, next we're going to look for AC. So we know OA, we know OC. So I'm going to zoom in here so I can write a bit smaller. We know that OA plus AC equals OC. So therefore, AC equals OC minus OA. Alright, so what we're going to get is simply OC, which is our, let's double check, 0, 2, minus 1, minus our OA, which was something minus 2, 4, 3, if I did not remember wrong. Okay, so 0 minus 2 is minus 2. 2 minus 4 is minus 2. Actually, 0 minus minus 2 is positive 2. Minus 1 minus 3 is minus 4. And to find the magnitude, we again go for 2 squared plus 2 squared plus 4 squared. So 16, 4, 4 root. So this will be root 24. So we know that AB is root 24. Now, another thing we have to find is BC. Alright, so to get BC, let's go for here. Right. So we know OB plus BC equals OC. We know, therefore, BC equals OC minus OB. OC is 0, 2, minus 1, minus OB, which was completely forgot. Minus 1, 3, 1. Okay, minus 1, 3, 1. So the answer to this is minus minus 1. So 1, 2 minus 3 is 1, minus 1 minus 1 is 2. Minus 1 minus 1 is minus 2. And then the magnitude, therefore, is 1 squared plus 1 squared plus minus 2 squared. Take the square root, which is root 6. Alright, so we know that this part is root 6. Okay, so this looks like a total mess, so we're going to move down here and redraw our beautiful right angle triangle. We know that this was root 5. This was 6, and the whole thing was root 24. Alright, let's get going. So how do we calculate the area of this? We simply go for the triangle AOC minus triangle OBC. Okay, so the equation for a triangle is half base times height. So OAC is going to be half root 5 times root 24. Okay, and OBC is half root 5 times root 6. Alright, so now let's get this going. So I am just gonna, this one looks slightly nasty here. What I'm going to do is do this, half root 5 root 24 minus root 6. Okay, root 5 times, so this could be written as times 4 minus root 6. Alright, so then what do I do next? This is half root 5 times root 6 to root 6 minus root 6, which is equal to half root 5 root 6, which is equal to half root 30, which is equal to root 30 over 2. That's the answer. So the area of the angle OAB equals root 30 over 2. Voila! So this was a bit of a very annoying algebraic calculation, but overall it's actually not a bad question. It's not a hard question. There are parts where it can get a bit tricky, especially being able to find the area. So hope you guys enjoyed this video. Remember to subscribe, and this is Ringo from 7.